Hi there! There are fundamentally three ways to build a circuit. Use a perforated board, use a solderless breadboard, and use a PCB, also called a printed circuit board. I'm going to show you today examples of the three of them, and I'll talk a little bit on how they are normally used. Let's now talk a little bit about the three ways of building a circuit. Here is an example of a breadboard, which is a solderless device where you can put your components on this central section, power them up wiring the right parts of the circuit on these rails on one side or one or the other of the circuit, and then make it work. Breadboards are simple to use because they allow for making quick changes to the circuit under test, replacing components or changing the connections in such a way that you can try different things and study how the circuits work. So these are more like for temporary solutions in building circuits. Let's see how this works. So we have basically one bus on this side and one bus on this other. So these elements are called bus. Each bus has two rails, one indicated with a plus sign and the red line, all these holes over here, and the other one indicated with a minus sign and the blue line, so the holes on the external part, and similarly on this side. Each of these lines of holes, the blue one and then the red one, each one of them has all the connections behind made in such a way that all the holes are electrically attached to each other, electrically connected to each other. So basically this will be the negative rail for your circuit, and this will be the positive rail for your circuit. And they are replicated also on this other side for simplicity. Sometimes you need to have different power supplies for the same circuit, or sometimes you just are closer to one bus than the other, so you make the connection one side of the other, depending on how convenient it is for you. The central part instead is divided in columns rather than rows. Each column is made up of 5 holes, and these 5 holes are electrically connected to each other from the back. And there are one column here and one on the other side, right in succession, and with a little space in between. Basically, these 10 holes are connected 5 here and 5 here independently, but there is no electrical connections between this column and this other. This and the fact that the holes are sized and spaced in a very specific way allows for easy usage of the integrated circuits. You see, when you have an integrated circuit which has several pins, in this case this one has 8 pins, it's very easy to connect it to a breadboard because just you align the pins with a number of holes that are on the two sides of the central section, and you have basically all the pins of the integrated circuit connect each one to a separate column, and so you can use this column to attach other components or wires to complete the connections with other components of the circuit and build the entire circuit. Wires are usually done this way. You can use simple wires, or you can use this one that are more common, and they have already, you see, a connector over here which can easily be pushed inside the hole and makes a very steady connection. So these are very useful, for example. So just to show you how this works, let me try to make a simple circuit. So let's see, for this circuit I'm going to connect the pin 4 of this integrated circuit. Pins are counted from here, 1, 2, 3, 4, and then 5, 6, 7, and 8 on the other side. So pin 4 over here with pin 8 on the other side, they are connected together. I will also connect the pin 2 with the pin 6. So this is 1, 2, and this is 5 and 6, pin 6. Here we go. Now I'm going to add to the circuit a capacitor, which I will connect between pin 2 and the negative rail. This is a electrolytic capacitor, so he is polarized. So this side is the negative one, and this other side is the positive. I will put the positive side toward pin number 2, and the negative directly on the negative rail, like this. Another thing I'm going to put is this resistor. This is going between pins 2 and 6. So I will put it, I'm sorry, between pins 2 and 7, not 6. So this one and this one. There we go. Okay, and then I'm going to put another resistor. This one will be connected on pin 3 on one side, and on the other side I will go to another column, external one that is not connected to any pin of the integrated circuit. So this is pin 3, and this is the other wire of the resistor, and I will attach to that same column this LED, which I will put the positive side on the resistor and the negative side on the negative rail. I will finish the circuit by adding one more resistor, and this one will go between pins 7 and 8, so it's gonna go over here. There we go. Now I'm gonna put two more wires here to basically connect the circuit that I just built with the power rail. Well, already the LED and the capacitor are already connected to the power rail, but I need also to give power to the integrated circuit. So the negative side of the integrated circuit is pin 1. So if pin 1 will go to the power rail with the negative sign, and the positive is going to go to the pin 8 right here, and this will go to the positive sign or red rail. Now, just for simplicity, for help me in connecting this circuit to my power supply with my alligator clips, I'm going to put these pins over here. So I will be able to use the alligator clips to easily connect the negative and the positive over here. You can see the circuit is working already. It was just a simple blinker, and the LED is blinking exactly the way I wanted to. So you can see how easily it is to build a circuit like that. Now, if I wanted, for example, to change the speed of the blinking, I could try to change this capacitor or change this resistor. These are the two components that regulate the speed of the LED, or the blinking of the LED. So it will be easy for me to pull one of these components and put another one instead, and so I can try different things, different solutions to build my circuits and try different things. The second way of building a circuit is to use a perf board, like this one or this one. These are just some examples. There are different varieties because of sizes or because how they are built. This one, for example, has holes that go through the board from one side to the other. In one side is just clean surface. On the other side there are pads, copper pads, as you can see, right in correspondence with each hole. What you do with this board, for example, is to take a component, like this one, put it from this side here, where there are no copper pads, and then on the other side solder the wires to the pads, so the component cannot move anymore. Then you add all the other components, and once you are done, you can add the wires to basically complete the circuit and connect all the components together. Once that is done, you can power it up, and at that point you have a perfect circuit which is durable because the component cannot be detached, and you can use it as is, for example. So basically the main difference between the breadboard and the perf board is that in the breadboard you can modify things on the fly and try different setups very easily. With the breadboard you construct your prototype in a durable manner, and you don't change it anymore usually. This is basically the same kind of concept, but in this case there are pads on both sides, so basically you can solder on both sides. This kind of double-sided perf boards are used when you have space issues, in the sense, for example, that when you allocate all the components there is not much space to do things like add wires and so forth, so you can work on both sides to build your circuit. This is an example of a circuit already prepared. You see there are components on one side, and on the other side there are the soldering done to hold the components in place. You can see the component cannot be moved anymore because now they are fixed on the pads from the other side. So this is the permanent version of a prototype that you can build and use it without dismantling anymore. Last case I want to show you, so number 1, number 2. Number 3 is the case of the PCB. The PCB is basically something similar to a perf board, but this time, instead of having a lot of holes covering the whole board, there are only holes to allocate the components that you need. In addition to that, each pad, each copper pad is connected through other wires that are basically imprinted on the board itself, so that the circuit is already prepared in place without any addition of further wires. So what you do in this case is basically you insert all the components on one side, like this, then you solder them on the other side, and you're done. There is nothing else to do. The circuit is ready to be used. So this is basically for permanent solutions, and you can use it for prototyping, but normally, since there is some work to do to create the design, to design the circuit itself, and then to hatch it on the board to create the PCB. So if you don't want to spend much time for just a single component, it's okay to use a perforated board to create your prototype or your single component, your single circuit to use. But if you have to do mass production, or if you have to build several prototypes or several circuits all the same, then maybe sometimes a PCB is more convenient, because even if you spend the time to design the configuration of the pads and their connections, once you have done that once, you can use that design to hatch several of these boards and build several of these circuits very quickly. Before concluding this show and tell, I just want to show you something I put together for myself. You need to know first that I work a lot with Raspberry Pi and Arduino boards. And when I experiment with them, I found useful to put all the pieces I need close to each other, to avoid spreading everything on the workbench and then being unable to move the prototype around without breaking it in pieces. So when I use such devices to run experiments, I use this board to test my prototypes. The board is essentially made out of a piece of thick cardboard that I covered with blue tape just for cosmetics. On one side, I glued some anti-skid pads to prevent the board from sliding on the workbench while I use it. On the other side, I used a hat gun to glue an Arduino Uno, a Raspberry Pi with its protective case, this tiny LCD, and a couple of breadboards. As you can see, there are also a few small trays that I created with my 3D printer. These trays have a double use. First, they can be filled with small components ready to be allocated on the breadboards. And second, if I have to use a bigger component that does not fit on either of the breadboards, I can put it in one of those trays and connect it from there to the rest of the circuit. The major advantage of this setup is that once I build the circuit, I can safely move it around without worrying or leaving loose pieces behind that can inadvertently be disconnected. So, okay, I believe now you had enough with the descriptions of my equipment and how I use it. On my next video, I will start showing some experiments with a few components, so we can see together how they work and how they can be used in more complex circuits. Also, if you have any specific topic you're curious about and you would like me to address it, please feel free to write a comment and tell me about it. Don't forget to subscribe to my channel, and see you soon. Happy experiments!